Hello everyone! Today we will have a new lesson about categories of programming languages. These are the following categories of programming languages. First, machine languages that are interpreted directly in hardware. Assembly languages that are thin wrappers over a corresponding machine language. High-level languages that are anything machine independent. System languages that are designed for writing low-level tasks like memory and process management. Scripting languages that are generally extremely high-level and powerful. Domain-specific languages that are used in highly special purpose areas only. Visual languages that are non-text based, and esoteric languages that are not really intended to be used but are very interesting, funny, or educational in some way. Let's talk about first machine languages. Machine language is the direct representation of the code and data run directly by a computing device. Machine languages features are registers to store values and intermediate results, very low-level machine instructions such as add, sub, divide, square root, which operate in these registers and/or memory. Labels and conditional jumps to express controlled flow. A lack of memory management support, programmers do that themselves. The machine instructions are carried out in the hardware of the machine, so machine code is by definition machine independent. Different machines have different instruction sets. The instructions and their operands are all just bits. Machine code is usually written in X. Here's an example for the Intel 64 architecture. Then proceed to assembly languages. An assembly language is an encoding of machine code into something more readable. It assigns human-readable labels or names to storage locations, jump targets, and subroutine, starting addresses, but doesn't really go too far beyond that. It's really isomorphic to its machine language. Here's the function from above on the Intel 64 architecture using the GAS assembly language. And here's the same function written for the part. Let's talk about high-level language. A high-level language gets away from all the constraints of a particular machine. High-level languages may have features such as names for almost everything, variables, types, subroutines, constants, modules, and also complex expressions, control structures such as conditional switches or loops, composite types like arrays and structs, and type declarations. High-level languages also is used for type checking, easy, often implicit ways to manage global, local, and heap storage, subroutines with their own private scope, abstract data types, modules, packages, classes, and exceptions. The previous example looks like this in Fortran 77. Take note how the code begins in column 7 or beyond. And like this in Fortran 90 where the column requirements were finally removed. And like this in Ada. and like this in C and C++, and like this in Java and C#. And like this in Scala, and like this in Kotlin. High-level languages also look like this in JavaScript and like this in CoffeeScript. Also like this in Smalltalk and like this in Standard ML. And like this in Elm, also this in Haskell. High-level languages also for this in Julia and in Lisp. Also in Clojure and Prolog. For Erlang and Perl. High-level languages like this in Python and like this in Ruby. Also high-level language for Go. This in Rust and like this in Swift. Also like this in K. Let's proceed to system languages. System programming languages differ from application programming languages in that they are more concerned with managing a computer system rather than solving general problems in healthcare, game playing, or finance. In a system language, the programmer, not the runtime system, is generally responsible for the following: memory management, process management, data transfer, cache, device drivers, directly interfacing with the operating system. So here's the scripting languages. The scripting languages are used for wiring together systems and applications at a very high level. They are almost always extremely expressive. Take note that they do a lot with very little code, and usually dynamic, meaning the compiler does very little, while the runtime system does almost everything. Well, the esoteric languages. An esoteric language is one not intended to be taken seriously. They can be jokes, near minimalistic or despotic, purposely obfuscated, or non-deterministic. So let's talk about the programming paradigms. So the programming paradigms have imperative and declarative. Under the imperative are procedural, object-oriented, and parallel processing, while under declarative are logic, functional, data flow, and database. So in programming paradigms, very often a programming language is created to help people program in a certain way. A programming paradigm is a style or way of programming. Some languages make it easy to write in some paradigms, but not others. You should know these common paradigms, as we said a while ago. Imperative, programming with an explicit sequence of commands that update state. In declarative, programming by specifying the result you want and not how to get it. Structured, programming with clean, go-to-free, nested control structures. In procedural, imperative programming with procedure calls. While in functional applicative, the programming with function calls that avoid any global state. In function level or combinator, programming with no variables at all. While in object-oriented, programming by defining objects that send messages to each other, objects have their own internal encapsulated state and public interfaces. Object orientation can be. Under these are the class-based objects such as get state and behavior based on membership in a class. While the prototype-based objects get behavior from a prototype object. As an event-driven or driven, programming with emitters and listeners of asynchronous actions, while the flow-driven, programming processes communicating with each other over predefined channels. As a logic-based, programming is by specifying a set of facts and rules. An engine infers the answers to questions. While constrained, the programming by specifying a set of constraints, an engine finds the values that meet the constraints. While an aspect-oriented, programming cross-cutting concerns applied transparently. In reflective, programming by manipulating the program elements themselves, and in array, programming with powerful array operators that usually make loops unnecessary. Under the imperative programming, control flow in imperative programming is explicit. Commands show how the computation takes place step by step. Each step affects the global state of the computation. Here is an example of imperative programming. In structured programming is a kind of imperative programming where control flow is defined by nested loops, conditionals, and subroutines rather than via gotos. Variables are generally local to blocks or have lexical scope. This is the example of structured programming. Early languages emphasizing structured programming such as ALGOL 60, PLI, ALGOL 68, Pascal, C, AIDA 83, Modula, Modulo 2, structured programming as a discipline is sometimes thought to have been started by a famous letter by Edgar Dijkstra entitled Go to Statement Considered Harmful. Let's proceed to object-oriented programming. OOP is based on sending of messages to objects. Objects-oriented or objects respond to messages by performing operations, generally called methods. Messages can have arguments, a society of objects each with their own local memory and own set of operation has different field than the monolithic processor and single shared memory field of non-object-oriented languages. One of the more visible aspects of the more purish OO languages is that conditionals and loops become messages themselves, whose arguments are often blocks of executable code in a Smalltalk-like syntax. For example, this can be shortened to like this. Many popular languages that call themselves OO languages, such as Java or C++, really just take some elements of OOP and mix them into imperative-looking code. In the following, we can see that length into upper are methods rather than top-level functions, but the for and if are back to being control structures. So the first object-oriented language was Simula 67. Smalltalk followed soon after as the first pure object-oriented language. Many languages designed from the 1980s to the present have labeled themselves object-oriented, notably C++, Clause, Object System of Common Lisp, Eiffel, Modula 3, ELDA 95, Java, C#, and Ruby. So how about declarative programming? Control flow in declarative programming is implicit. The programmer states only what the result should look like, not how to obtain it. No loops, no assignments, and so on. Whatever engine that interfaces code is just supposed to go get the desired information and can use whatever approach it wants. The logic and constraint paradigms are generally declarative as well. In functional programming, control flow is expressed by combining function calls rather than by assigning values to variables. That's like the example. And another example, in functional programming, we can do better by using the cool operator. Here is, for example, the operator has very low precedence, so you can read things left to right. Notice that you wouldn't write maps square, right? So you would write map square. We can do something similar about, but we have to use function composition. You know that f(of)(x) is look like this. With functional programming, there are no commands, only side effect-free expressions. Code is much shorter, less error-prone, and much easier to prove correct. There is more inherent parallelism, so good compilers can produce faster code. Some people like to say functional or applicative programming is programming without assignment statements. One just applies functions to arguments. Examples: Scheme, Haskell, Miranda, ML. Function-level programming does away with the variables. One combines functions with functions as combinators, such as F, P, F, L, and J. Many languages have a neat little thing called comprehension that combine map and filter, just like the example. So let's discuss about logic and constraint programming. Logic programming and constraint programming are two paradigms in which programs are built by setting up relations that specify facts and inference rules and asking whether or not something is true, like specifying a goal. Unification and backtracking to find solution or satisfies goals takes place automatically. Languages that emphasize the paradigm are Prolog, GHC, Parlog, Vulkan, Polka, Mercury, FME. So, discussing or talking about languages and paradigms, one of the characteristics of a language is its support for particular programming paradigms. For example, Smalltalk has direct support for programming in the object-oriented way, so it might be called an object-oriented language. OCaml, Lisp, Scheme, and JavaScript programs tend to make heavy use of passing functions around, so they are called functional languages, despite having variables and many imperative constructs. There are two very important observations here. First, very few languages implement the paradigm 100%. When they do, they are pure. It is incredibly rare to have a pure OOP language or a pure functional language. A lot of languages have a few escapes. For example, in OCaml, you will program with functions 90% or more of the time, but if you need state, you can get it. Another example, very few languages implement OOP the way Alan Kay envisioned it. Another is, a lot of languages will facilitate programming in one or more paradigms. In Scala, you can do imperative, object-oriented, and functional programming quite easily. If a language is purposely designed to allow programming in many paradigms, it's called a multi-paradigm language. If a language only accidentally supports multiple paradigms, we don't have a special word for that. So that's all for the discussions about the categories of programming languages. Thank you for watching and have a nice day.